How might we define the best architecture for a boundary between wallets and service providers on one side of the boundary, and then Bitcoin-powered applications on the other side? That is to say, what are the things that make an application a Bitcoin-powered application? What are the differentiating factors between internet and metanet, so to speak? Why might we need such a boundary? Why are these things valuable to consider? What I want to do is lay out some of the things that I think should be in any boundary specification that might be created between, on one side, wallets and service providers and APIs that facilitate Bitcoin applications, and then on the other side, the Bitcoin applications themselves. I'm not going to speak in specific terms of specific substrates, messaging layers like HTTP, Auth-Write, or cross-document messaging for things like how a browser plugin might communicate. But what I will say is that we can define this messaging layer, which I will call a substrate, for selfish reasons, as that's what the Babbage SDK calls it. I will define this substrate in abstract terms so that we can send data structures between applications on one side and wallets or service providers on the other side across this boundary, this messaging layer. So we have an abstract messaging layer, which is how an application communicates with a wallet or service provider. And on top of this, we can begin to define the structures and requirements for what an application might want to do, and thus what makes it a Bitcoin application as opposed to just any other application. I think the most obvious place to start if we want to define something for a Bitcoin application is the creation of Bitcoin transactions themselves, because in order for an application to interact with the blockchain, it must create transactions that mutate the state of the blockchain. Therefore, applications need a way to create Bitcoin transactions, and our interface that sits in between an application and a wallet or service provider needs a way to create Bitcoin transactions, and this should be done in the most open-ended way possible. So, what comprises a Bitcoin transaction? What are the things that an application might want to include in the Bitcoin transaction that it requests be created by the wallet or service provider? There are a number of things that are included in any Bitcoin transaction, and we can find these things by looking at the Bitcoin protocol. I would say the most important and useful things inside of a Bitcoin transaction, at least in the basic case, are inputs and outputs. Every transaction contains at least one input and at least one output. Fairly certain on the outputs, definitely certain on the inputs. I mean, you could just unlock a bunch of inputs and send them nowhere. I'm getting off track, pardon me. So our boundary specification should define an open-ended way for applications to specify the things they would like to see in a Bitcoin transaction and then return that Bitcoin transaction to the application so that the application can make use of it in some way. So, outputs, let's start there. We need a way to have a message, which is a request from an application, that a Bitcoin transaction is created, and this request comprises inputs and outputs that the application would like to see. So, focusing on outputs here, we have a list of 0 or more outputs that the application would like to see in this transaction. Now, why not 1 or more? Well, that's because sometimes all the application wants to do is redeem some inputs, and we'll get there in a second. So an application creates a Bitcoin transaction and it wants outputs. Each output has a script, a lock, a program that defines the conditions under which the output can be spent. And then the output also has a satoshis, a number of satoshis rather, the things that are being locked in this output, the Bitcoin tokens themselves. So, script and satoshis in each of the outputs. That's fairly simple. I think people who define wallets and applications and the interfaces between them in a standard way can get behind that, right? The next thing, if I as an application am now free to request a Bitcoin transaction with any output scripts that I want and any number of satoshis within those outputs as I want within a Bitcoin transaction, is I want to be able to redeem things. I want to be able to spend tokens, thus updating the state of those tokens within my transactions. Therefore, as an application, I also want to be able to redeem and unlock output scripts and request that these inputs be included in the transaction. So we have inputs as well as outputs. And for each input, what do we need? Well, the Bitcoin protocol is very specific. It calls for the transaction ID of the transaction which created the output, which we are now spending in our input. It calls for the output index, the specific output from that transaction which we are now spending. And then it calls for the unlocking script, the program that will serve to unlock and enable the spending of the output which we are now consuming as input in this transaction. So, our boundary interface between applications and wallets and service providers should facilitate a way for applications to say, here is a transaction output that I would like to spend. Here is the program that unlocks and spends this transaction output. And will you please include this in the Bitcoin transaction that I am requesting be constructed? So now the application can request outputs that it would like to see and inputs that it would like to spend. And then the response from the wallet or service provider will comprise a message containing the completed transaction or an error indicating that the transaction cannot be created for some reason. Perhaps because the user does not have sufficient funds within the wallet or service provider, and the user has declined the request to create the Bitcoin transaction. These are valid reasons to have errors be thrown. Now, there are some things that the wallet or service provider will need to do in order to facilitate these requests. I mentioned before that there could be 0 or more outputs, and there could also be 0 or more inputs in the transactions requested be created, in the transactions that are requesting to be created, rather, by the applications. So, why is this? How is this possible? How can an application request that there can be a transaction with some outputs, but it didn't give any inputs to spend? Well, that's because in a Bitcoin context, the expectation is that the wallet or service provider is able to manage UTXOs, fund the transaction with any needed inputs, and then, if the inputs being unlocked by a particular application in a particular context exceed the value of the outputs that the application is requesting be created as part of this transaction, capture the remaining funds as change, bringing them back into user control. User control being control of the person who is the sender of this Bitcoin transaction through the wallet or service provider or MetaNet client, as I will call my system. So, we have the ability to define 0 or more inputs, and then the ability to define 0 or more outputs within the application. And the wallet or service provider will generate adequate change to capture any surplus coins while ensuring that sufficient funds are provided via additional inputs where applicable to ensure that the transaction is valid and acceptable by the Bitcoin miners. So as an application, I can now define any set of inputs that I would like to consume, provided that I am able to successfully unlock them, which is trivially verifiable by wallets and service providers and MetaNet clients. And I can also specify any new outputs that I would like to see in the Bitcoin transaction when it is created. The user can then be prompted sort of transparently to the application by the wallet or service provider or MetaNet client as applicable, as per the user's preferences, etc. And then we have the standard message for the completed Bitcoin transaction, which is returned to the application by the wallet or service provider or MetaNet client. I think I'm going to make a series of videos here, this being the first in the series of videos. So this video is about the specific function within this standard interface that needs to exist between applications and wallets or service providers or MetaNet clients for the creation of Bitcoin transactions. However, there are other functions such as data encryption and the creation of digital signatures and the management of tokens within baskets and other things like this that can be defined as part of this interface between applications and wallets or service providers or MetaNet clients. So I think those are going to be other videos. I'm just kind of going along here and thinking about these things and letting people know my thoughts. So some more thoughts about the specific function of creating Bitcoin transactions, which is, I think, core to what we would call a Bitcoin application. We have inputs, we have outputs, and each of the inputs that is specified be spent and consumed and used within this function by the application should contain relevant SPV information. What this means is that when an application goes to the wallet or service provider or MetaNet client and says, I wish to spend these inputs, here is the unlocking script, here is the TXID, and here is the output from that transaction that I would like to spend, the application should also need to provide the input transaction so that the wallet or service provider or MetaNet client can verify that the transaction is A, legitimate, as in it is proven in the blockchain via a Merkle proof provided by the application, and B, that when the unlocking program is executed in the context of the locking program that was originally created for that output, the program executes successfully, therefore allowing the wallet or service provider or MetaNet client to easily confirm that a valid unlocking solution was provided to actually redeem the output that is being spent by this transaction, or attempted to be spent by this transaction. So, that poses an interesting question and problem, though. How are applications expected to get the unlocking scripts? Well, I mean, that's something that can be done on an application-specific way and in a UTXO-specific way, right? Certain applications know how to unlock certain outputs, and other applications certainly don't. Why does my application for updating a land registry with new data, why does that need to know how to unlock the token associated with my Duro dog or something like this, where now I have, this other output, this other type of output used by another application? Obviously it doesn't, and obviously each application has specific functionality that is custom. And therefore we allow any type of script to be created in outputs, and we allow any type of script to be redeemed in inputs, and we just check that the programs successfully lock and unlock. So certain applications will know how to unlock and update and use certain types of outputs, but that's in the purview or the domain of particular applications. The other things relate to the actual transactions themselves, the input transactions that are being provided. How does an application know what the Merkle proof is and the raw transaction itself? And how does the application know about the inputs that they're trying to spend to begin with? And that's where it gets a little interesting. Now we have a way, or now we have a problem where applications don't necessarily, they need to track state somehow. They need to have some way of knowing what are the inputs that I need, and how can I spend them. And that's where we can start to talk about output baskets. So each output, in addition to having script and satoshis, you can also stipulate a basket where that output can live. And then the wallet or application, or service provider or Metanet client would keep track, without knowing the correct unlocking solution to this custom output script, would keep track of the output within a basket. And that basket could be controlled by the user. Perhaps permission could be done transparently to the application, ensuring that the user is okay with the application inserting a new output into this basket. And then the Metanet client or wallet would track specific spending instructions created by the application for the output within that basket. And then the application could later request the specific UTXOs that are currently within that basket, and the application, the wallet rather, would return to the application the specific UTXOs, including raw transaction and the SPV data and the spending instructions provided when the output was originally created. In this way, we arrive at our second function, which is a function for requesting outputs that are currently stored or tagged within specific output baskets. So our wallet to application interface now has a function for creating transactions, and the inputs, you need to provide SPV information so that the wallet or Metanet client or service provider can verify the legitimacy of the coins being spent. But then the application can provide the unlocking script and spend any type of input that it would like. And the other part of that function is the ability for applications to stipulate the outputs, including the script, the satoshis, and if any baskets that the application requests that this wallet or Metanet client or service provider tracks this output in. So the custom outputs created by specific applications are stored in specific baskets. The Metanet client or wallet doesn't realize that doesn't realize the specifics of how to unlock this particular UTXO, but it tracks it in the basket all the same and then is able to return it. That's the first function. And then, of course, if it ever does get spent, then the Metanet client would automatically realize that this output is no longer in that basket because it's just been spent and used as input, and therefore not make it available in that basket any longer, right? So then the second function is just a get transaction outputs function. So given a basket and perhaps some search criteria, a regular expression which can be applied to the output script within the UTXO that is stored within that basket, the MetaNet client or wallet would return to the application a list of UTXOs that meet the criteria, including all information that would be needed to use them as inputs, and the spending instructions that were included. So that is the interface, the transactional interface, the parts of this that facilitate the creation of a Bitcoin transaction between wallets and applications. This is very open-ended, and it allows for applications to define any type of custom token they would like, store it into an output basket, and then later redeem it as input. They could use alternative state management systems and manage their own state independently, not making use of this convenient basket thing, which, if you think about it, really would only apply to a single user, because, of course, if you have like a UTXO that 10 people could update, then you wouldn't want it stored in one user's basket because somebody else could update it without the user knowing, and then of course you run into problems. So baskets are for private storage, and state management for the wider world would need to be done by the application in some way, which is beyond the purview of this specification of a boundary between the wallet and the application, because now it's a boundary between the application and the wider world. That's for the application to figure out. But if we're to define an interface that allows for the most open-ended method by which inputs can be redeemed and outputs can be created and tracked in baskets for custom tokenization features on Bitcoin SV, and the use of those within the largest number of applications possible, then our wallet to application interface would need to include support for this ability to track specific outputs within baskets and then allow the user to make decisions about which applications are allowed to use or access data within certain baskets. That is, I think, going to be the end of this first little video talking about the wallet to application interface and why I believe certain components of this interface are necessary. This is really the core of the interface, which facilitates the creation of Bitcoin transactions and thus the ability for applications to interact with the Bitcoin blockchain. I'd just like to emphasize at the end here that the wallet allows the user to use any input from anywhere as long as its unlocking conditions have been met. Capturing change when the user redeems more money than the transaction outputs stipulated by the application require, and thus adding to their balance within the wallet or MetaNet client. And then, when the application requests that outputs get created, and the application didn't maybe even provide any input, so maybe the application says 0 inputs, but I want to see 2 outputs, each with different amounts, the wallet would automatically fund the transaction, making it easy for application developers to focus on their specific use cases and the specific relevant inputs and outputs in Bitcoin that they care about without needing to fund things or generate change or deal with address reuse or key management. So those are some of the benefits that I think exist within an open-ended wallet to application interface when it comes to Bitcoin transactions. In the next video, I think I'll talk about data encryption and how a wallet to application interface could facilitate protection for user data with user-held keys. We'll talk about encrypting and decrypting data and then sharing data between users of the system in a way that allows it to remain secure and accessible only to those with authorization. So I encourage you to go check that out, the second video in the series. Thank you for taking the time.